For this lesson, we're going to be working on what are called factorials. So to get started, we're going to review one specific grade 11 concept that's going to be very important. So we're going to start by using the FOIL method to simplify these. And what we're going to do with our FOIL method is we're going to start by multiplying this one. So that's our first one. So the F in FOIL stands for first. So we do x times x, which is x squared. And then next is the O, which is outside. So we do this next one. So x times 4 is 4x. Then the inside, so negative 3 times x is negative 3x. And finally, our last one, negative 3 times 4, which is negative 12. Our next step here is to collect like terms. So remember, the only things we can combine are things that have the exact same variables. So in this case, that would be our 4x and our negative 3x. So we would have x squared plus x minus 12. And that would be our final answer. Let's do one more quick example. So our next one here is x minus 7 multiplied by x minus 6. So again, we draw our little arrows here. I'm just going to do this one a little quicker because it's the same process as the last one. So x times x is x squared minus 6x minus 7x plus 42. So be mindful of those double negatives. So negative 7 multiplied by negative 6 would be positive 42. And again, I collect those like terms. So those are terms that have the exact same variables raised to the same exponent. So x squared minus 13x plus 42. And that is our final answer. So now we can move on to our next topic. So what we're going to be learning about are called factorials. And just a quick reminder of some terminology is that a factor is a value that's involved in multiplication. So for example, in the above examples we did, when we have x plus 3 and x plus 4, because we are multiplying those would be considered factors. Same as when I factor something out and multiply it back, those all are considered factors. Now a factorial, which is denoted by this little exclamation point, indicates the multiplication of consecutive natural numbers. And our natural numbers are just our positive integers, so 1, 2, 3, 4, continuing on. And how I write out a factorial, or how I calculate a factorial, is n factorial equals n times n minus 1, so the one below it, times n minus 2, the one below that, and then I continuously decrease by 1 until I get to the number 1, and that is where I stop. So scientific calculators do have a button for this. You may have noticed a little n with an exclamation point on your calculator before, but most of them max out at 69 factorial, and the reason being is it gets so big that 70 factorial is already larger than 1 times 10 to the 100. So your calculator just can't have numbers that big, so we need to learn how to simplify these things a bit in order to work with them. So let's start with a few examples. So we're going to do each of these as a product of factors, and we're not going to use a calculator here. Or at least we're not going to use the factorial button. I want you to actually see how the factorial works out. So this first one here, we have 3 factorial. So to calculate the factorial, I do 3, and then I multiply that by the number below it, and the number below that until I get to 1, and that is where I stop. So 3 times 2 times 1 is going to give us 6. So 3 factorial is equal to 6. For our next example, we're going to do this with 5 factorial. So we start at 5 and we multiply that by the number below. then multiply by the number below, until we get to 1. Now, if I multiply 5 times 4 times 3 times 2 times 1 is 120. So although the 1 doesn't really change our answer because multiplying by 1 is just whatever the number was, please make sure to include it because our factorials always end at 1 when we're expanding. And when we start canceling things in the next example, you'll understand why it's important to fully write out a full factorial. Let's try a couple examples that are a little tougher. So this next one here, 7 factorial divided by 4 factorial. To start, we're just going to expand those two factorials. So we have 7 times 6 times 5 times 4 times 3 times 2 times 1. And all of that is going to be over 4 times 3 times 2 times 1. Now there's something I want to bring to your attention here. If you notice, all of this stuff is the same as all of this stuff. So all of this is for factorial. So if I want to write 7 factorial with a 4 factorial, I just need to take out the stuff before 4. So I'll show you that again in a moment. Now, we can cancel some stuff here. So I have a 1 and a 1. Those go. 2 goes. 3 goes. 4 goes. So what we actually canceled out was this full 4 factorial. So now all I have is 7 times 6 times 5, and that gives me 210. Now the other way I could have written this, which is important to note, is I could have said 7 times 6 times 5, and instead of writing times 4 times 3 times 2 times 1, I could have just said times 4 factorial. And then in the denominator, I could have just left it as 4 factorial. And then when I went to cancel stuff, I could have just done that and canceled out that 4 factorial. And no matter what, I would have still been left with 7 times 6 times 5, which is 210. So the solution written in pink is typically the way we write this, especially when we get to really big numbers and we don't want to write them all out. So that brings us to our next example, where we have 95 factorial divided by 92 factorial. Now, we need to start by expanding these factorials, and I definitely do not want to write 95 factorial expanded all the way down to 1. I don't have enough room on my page. It would take up way too much space. So how I write this is I'm going to write 95 times 94 times 93 times 92 factorial. So this 92 factorial, what this represents would be the 92 times 91 times 90. If I kept going on forever and ever, that part sums up all of that stuff for us. Now in the denominator, we also have a 92 factorial. So now you can see why I chose to stop it at 92. That was done intentionally so that I can cancel that 92 factorial in the denominator. So cancel, cancel, and we're left with 95 times 94 times 93. And now you can do this by hand. If you put this part in your calculator, that's okay. We're just avoiding using that factorial button. So this will give us 830,000. The systems are all back up and running. Thank you. 490. And that is our final answer. So now we're going to take this one step further and we're going to start solving for the value of x. And we're going to practice one thing we've practiced before here, which makes it a little complex. So bear with me as we go through. So this first example, we have x factorial all over x minus 2 factorial equals 20. And we need to solve for the value of x. So similar to before, I'm going to start by expanding my factorials. So in the numerator, I would have x, and then what we would do is we would now multiply it by the number below it. And how we find the number below it is we're always subtracting 1. So for example, when we were looking at 5 factorial, we did 5, 4, 3, 2, 1. And how we got to the next number was we just subtracted 1. So I'm going to do the same thing here. So subtract 1 and subtract 2, and I'm going to stop there. And the reason I'm stopping there is because I have an x minus 2 factorial in the denominator, and it would be very convenient if I could cancel that out. When we're solving things with factorials, we will always have to cancel something out because we can't really solve things with a full factorial in there. So let's cancel that out, and we're left with x minus 1 equals 20. Now solving this gets a little tricky because we have an x squared. So if you recall from our review, or maybe you haven't done this in quite a while, what we need to do is we need to first start by expanding out these brackets. Next, in order to solve a quadratic, which is what this is because we have an x squared, it needs to be equal to 0. So let's move that 20 over to the other side, so it's equal to 0. Remember, when that 20 comes over to the other side, our sign changes because of opposite operations. And now, to solve this, we have to factor it. So our two numbers that multiply to 20 and add to, negative 20 and add to 1 will be negative 5 and positive 4. And now I set both of these brackets equal to 0. X minus 5 equals 0, and x plus 4 equals 0. And I solve for x. So x equals 5, and x equals negative 4. Now we have two answers, but we only need one of them. So if you remember from the beginning of the lesson, we said that our factorials only work with positive integers. So only 1, 2, 3, 4. We can't have negative numbers. So what that means is we reject this one here. So the answer we want is x equals 5. So that happens a lot with factorials where we will get a positive answer and a negative, and we don't want the negative. It is okay if we have two answers. If they are both positive, that's fine. But if there's a negative one, we cannot use it. All right, let's try B. It's a little bit different. So B has x minus 1 factorial over x minus 2 factorial. So again, I'm going to start by expanding my numerator. So I start at x minus 1, and then from there, I'm going to subtract 1 again. So I get x minus 2, and I'm going to leave that one as the factorial because I have an x minus 2 factorial in the denominator. Next, I'm just going to cancel those factorials because I have a matching one in the numerator and in the denominator. And so now I have x minus 1 equals 25. And let's get x all by itself. So we move that 1 over. X equals 25 plus 1. And we get x equals 26. And that's our final answer. Let's quickly try the next two because they're very similar to these. So for C, we have n minus 1 factorial all over n minus 3 factorial equals 30. So again, we start by expanding that first one. And I'm going to stop at n minus 3 factorial because I have an n minus 3 factorial in the denominator. So now I can cancel that out. And now, just like before, I have a quadratic here. So I need to start by multiplying it out. So multiply this whole thing out. N squared minus 2n minus n plus 2. And I need to make sure it's equal to 0. So we move that 30 over to the other side. And now we collect some like terms. All right, so now I have to factor this. So two numbers that multiply to negative 28 and add to negative 3. So we'll have x minus 7 and x plus 4. And now we set both of those brackets equal to 0. Oops. So we get x equals 7 and x equals negative 4. Again, we cannot have a negative, so we have to reject this answer here, which leaves the correct answer being x equals 7. All right, one more example, and then we'll do one quick little extra proof at the end. So our next one here, we have n factorial all over 3 n minus 1 factorial. So what I'm going to do is I'm going to start by expanding some things. So we have n, and then we subtract 1. So I'm going to stop at n minus 1 factorial because I have an n minus 1 factorial in the denominator. Now I'll cancel those out. And now we want to get n all by itself. So to do that, we'll multiply by 3, n equals 12. And that's our final answer. Okay, the last thing we're going to do is a proof. So in your calculator, if you put in 0 factorial, you're going to get the answer 1, which seems a little strange. So I want to go through the whole process and prove to you why that happens. So what we're going to start with is we're going to just start with the fact that n plus 1 factorial is equal to n plus 1. And then for my next one, I'll just have n factorial, right? So every time I move down, I subtract 1, just like I went from 5 to 4 to 3. So because I subtract 1 each time, then I would go from n plus 1 just to n. Now, I'm going to go and I'm going to rearrange this. So my goal is to get n factorial all by itself. So I'm going to divide by n minus 1 here. Sorry, n plus 1. And if I do it there, I'm also going to do it here. So now I have n plus 1 factorial all over n plus 1 equals n factorial. Next, I'm going to try subbing in n equals 0. And I'm just going to write it with zeros instead of n's. 0 plus 1 factorial all over 0 plus 1. And then I'll get 1 factorial over 1 equals 0 factorial. And I get 1 equals 0 factorial. And then what I do is I can write a little box here. That just means that I've proved it. You can also write QED, which basically in Latin means that you've proved it. It means something in Latin, but I don't know. But that's basically how you denote that you went through and solved the whole thing.